Okay, so we are going to go ahead and run through these examples that we didn't get to in class. This is just adding a simple fraction and a complex fraction. So we have to deal with the complex fraction and make sure we make it into a simple fraction. And one way you can do that is on the denominator, you want to get a common denominator for 1 and b over x. And of course, that's going to be x. So you're going to multiply the 1 by x over x. And you will have, in the numerator, you will have 4 still. Nothing happened there. And then you have x over x plus b over x. And so that fraction becomes 4 over x plus b over x. And then when you change this to a multiplication problem, 4 divided by x plus b over x is the same thing as 4 times the reciprocal, so x over x plus b. And therefore, that becomes 4x over x plus b. So that is this fraction right here. We've made it into a simple fraction. And now we just need to add a over x plus that simplified fraction, 4x over x plus b. The common denominator for these two fractions is going to be x times x plus b. So I'll need to multiply this first fraction by x plus b over x plus b. And I'll multiply this second fraction by x over x. So first fraction, we're going to have ax plus ab over x times x plus b. And the second fraction is going to become 4x squared over x times x plus b. And now we can just add up the numerators, ax plus ab plus 4x squared all over x times x plus b. And that is a simple fraction with no fractions in it. Next, we have multiplying two complex numbers, and all we have to do here is just use the distributive property, and so on. So 5i times 4 is 20i. 5i times 3i is 15i squared. And then minus 2 times 4, which is 8, and minus 2 times 3i, which is 6i. So we've got 20i minus 6i is going to be 14i. And then we've got 15i squared, which is 15 times negative 1, and then minus 8. So we have 14i plus negative 15 minus 8, so that's minus 23. And now we need to write it in the correct order. Real number first, imaginary number second. Okay, this is the one that we did in class, but we were in a rush, so I'm going to go ahead and do it again. We have 4 equations and 4 unknowns. And the thing we have to do is make sure we use all 4 equations, because if we don't use all 4 equations, we may end up with one equation that still has 2 unknowns in it. So we're going to try to make sure and use all of the equations. So as we did in class, I'm going to look at this equation right here, c equals 3a, and I'm going to put 3a into the second equation. So substituting 3a for c, cd becomes 3ad, and that equals 6. Now, I'm going to substitute the fourth equation into the first equation, but I want to do that for b, not d, because d is not in the first equation. So I'm going to go ahead and rewrite this last equation so that b is by itself. That would be if you add b to both sides and subtract d on both sides, you end up with b equals 2 minus d. And now I'm going to plug in 2 minus d right here in the first equation. So I'm going to have a times, substituting 2 minus d for b right here, and that also equals 6. Now the temptation here is to just set a times 2 minus d equal to 3ad, because they are the same thing. They are both 6. But that's not a good idea, because then you'll have one equation, but you'll still have 2 unknowns. So that's not going to work out for you. So from this equation, you can divide by 3 on both sides, and you're going to get that ad is equal to 2. If you use the distributive property on the first equation, you're going to have 2a minus ad is equal to 6. So now you can see that you have an ad here, and you also have an ad up here, so you could actually put 2 in for that ad, and your equation would just have 1 unknown left, so that works. So writing that first equation here with 2 substituted in for ad, I'm going to have 2a minus 2 equals 6. So 2a is equal to 8, and a is equal to 4. Now that I have a, I can go back and find b, because I know that ab is 6 if you look at the very first equation. So 4b is equal to 6, which means that b is equal to 6 over 4, which is 3 halves. So b is 3 halves. I'll go ahead and write the answers over here. So a is 4, b is 3 halves. We can see that c is equal to 3a by the third equation. So c is equal to 3 times 4, which is a, and that's 12. So c is 12. And then d is 2 minus b. So d is equal to 2 minus 3 halves. And that's going to be 4 halves minus 3 halves, which is 1 half. So d is 1 half. So those are the solutions to that system of equations. Last one, find the values of all 4 variables. So we want to make sure, again, that we are using all 4 equations and that we don't accidentally cancel something or have 2 unknowns in one equation. We don't want that. So we need to kind of reduce this down so that we only have 2 unknowns and then finally 1 unknown. So I'm going to use this third equation first. I'm going to substitute 3r sub c in for rp in the first equation. So you've got r sub p here, and you've got r sub p here. This is what it equals, so I'm going to put that into the first equation. So I'll put 3rc for r sub p, and then t sub p, and that equals 693. For this fourth equation, I'm going to go ahead and solve for t sub c. I'll have 12 minus t sub p, and I'm going to put that in this here in for t sub c in the second equation. So that's going to be r sub c times 12 minus t sub p, and that equals 165. So I have the first equation is going to be, if I divide both sides by 3, I'm going to have r sub c, t sub p is equal to 231. For this equation, if I distribute, I'll have 12 r sub c minus r sub c t sub p equals 165. And again, just like on the last problem, I can plug in now 231 in for r sub c t sub p in that second equation. So 2r sub c minus 231 is equal to 165. So 12r sub c is equal to 396. And if I divide both sides by 12, I'm going to get 66. And now I just need to go back and plug 66 in to all the places and then find the rest of the things. So r sub c, I can plug that into the second equation. And that equation says r sub p is equal to 3 times r sub c. So that's 66. So r sub p is equal to 198. And now I can take r sub p and plug it into the first equation. So I'm going to have 198 times t sub p is equal to 693. So t sub p is 693 over 198, which is 3.5. And now I can plug that into the last equation to get t sub c. So I would have t sub p would be 3.5 plus t sub c is 12. So t sub c is going to be 12 minus 3.5, and that is going to be 8.5. So those are all your values. That's r sub p, t sub p, t sub c, and r sub c.